Sì!
رقصة قبيلة. হ্যালো, সফিউর, তুমি কি শুনতে পাচ্ছ?
Hi. Hello. Hello. Can you hear me?
Yeah, we're hearing you.
Hi.
Hello.
Hello, everyone. Hello. Can you hear me?
Yes,
Yes,
Laushi.
let's I can hear you.
Okay.
It.
الصبح سبحان الله يا الصباح كي داير
بردي وصل بردي.
المر حياتنا كنخدم انا هاد الشفت دابا كنخدمها ما ديال 11 ونص بزاف تجا الوالو وتغيني ساليزا انت تغيني ساليزا مرت غيني ساليزا الله يرحم بها الوالدين ما فيش لي تاع الو ايمان
Hello, Laushi, can you hearing me?
Hello, and we begin together. The first one,
Present,
outside
Lashi. Yes, Lashi, I'm present.
Yes, Lofty.
6210
Yes, Lofty. It's me.
222. Third one,
Lovely, it's
hello,
me.
the third.
It's me, Lovely. It's me.
You should be clear because I can't hear. Okay, Zenbei. Oh, Zenbei is not here. 6211 6211 1218
Lofty, yes.
伊利
Lazy. Yang penampilan gue.
伊利
أمير مس أمير كتسمعنا
卡西木
قلت لك وصافي بحال هكا واحد الوقت
OK 高沙1213
Present teacher.
OK next
Yes.
1209
Yes, ma'am, I'm here. Yes. Miss, I'm here.
OK 萨贝特1211 Hello 1211 1211 6207 6207 6207 1220
Oh, yeah, I'm present, miss. Okay.
20 1207
I'm here.
OK 1207
present miss present
OK 艾特6206
I'm here miss
1206 OK
I'm here, teacher.
1210
present teacher present
1204
Present, miss.
1205
Present, Lofty.
OK 华明
present teacher present
OK 6212
Present miss.
6212
I'm present.
OK 欧舒文
Present teacher.
1217蕾蕾安摩斯1216
present miss present
1215
Ok, je me fais encore bonjour, Vissal à votre écoute.
1215
Mhm.
1202
D'accord, madame. Est-ce que pourriez-vous, s'il vous plaît, juste me confirmer le nom
Ya,
et la
6203
réservation?
I'm here Laushi
Parfait. Sur l'indication de ma part, puis j'attends la
6204
personne qui a réservé.
I'm here teacher
6208
Parfait, 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 madame. Alors, vous m'avez dit, madame, que vous avez effectué cette réservation, sauf que vous vous êtes trompé. Par rapport aux dates. Mhm.
6208
Mhm. D'accord, madame. Donc, si j'ai bien compris votre demande, l'âge de vos enfants n'a pas été pris en charge, en considération. D'accord. D'accord. Alors, permettez-moi de vérifier quelques informations. Puis-je avoir, s'il vous plaît, l'âge de vos enfants, s'il vous plaît?
Mustafiz, can you mute yourself, please?
6201
You are the host.
I'm here, Laoshi.
6209
Present teacher.
1212
Present teacher.
于连 You didn't know your ID. Okay. Okay, I check this one. Oh, then it's not here. This one 6207 Hello 6207 1215 6208 Okay. First we'll review what we have learned last time. Maybe I think the mean value theorem for derivative. This theorem is difficult, but just the way it's difficult to prove it. But we can understand it from geometric geometric 几何的方面。Okay, and example one, this from the geometric side, this theorem tells that if we have a function y is fx is continuous on a closed interval AB, it's closed interval AB, and then we can find at least one point C such that f prime C. Here, f prime C is equal to is the slope of this tangent line. The slope of this tangent line is equal to the slope of the second line. It's connecting 2 points A, F, A, B, and B. We can find, always we want to find the proper C. And today we will learn antiderivatives. Most of the mathematical operations that we work with come in inverse pairs. we have learned addition and subtraction, multiplication and division, and explanation and result taking. In each case, the second operation enters the first, and vice versa. So one reason for our interest in inverse operations is their usefulness in solving equations. For example, we're solving x cubed is 8 involves taking rows. We have learned the multiplication. But if we want to solve this equation, we should know the inverse. This is the taking root. We have been studying differentiation in this chapter and the previous one. If we want to solve equations involving derivatives, we will need its inverse. This is called anti-differentiation or integration.
We can get even 3 words from you. Ma'am, someone is disturbing our class.
Come to my city, get taxed. Look how.
Okay, I'm mute. All right, turn off. Okay. And then we will learn the inverse. This means we have learned the differentiation, and today we will learn anti-differentiation, or we call it integration. Integration. And we call f, the f an antiderivative of this f on the interval I. If we have dx, this differentiation, dx fx is equal to fx on I. That is, if f prime x is fx. If f prime x is fx, then f, here, this one, this is f. F is called an antiderivative of f on the interval I. For example, we know sin prime x is equal to cos x, right? Cos x. And then we say sin x is an antiderivative of cos x. Right? And we know cos x prime is equal to cos x prime minus sin x, right? Minus sin x. So we say cos x is an antiderivative of minus sin x, right? Minus sin x. Okay, and we cite the antiderivative rather than the antiderivative in our definition. You will soon see why. Receive a message. It's late. Okay, and for example, one find an antiderivative of the function fx is 4x cubed on infinity on our real line. We found an antiderivative. This means we want to find fx, right? If fx is an antiderivative of 4x cubed, this means f prime x, right? F prime x is equal to 4x cubed, right? 4x cubed. So this means we can, from our experience with differentiation, we know that fx, we find fx is equal to x power 4, right? X power 4. Just from our experience, we can find fx is x power 4 in such one function. right? And a moment thought will suggest the other solutions to example 1. The function, we find fx is x power 4. And we know x power 4 plus 3, this prime, is also equal to 4x cubed, right? So this means x power 4 plus 3 is also an antiderivative of 4x cubed, right? So we can also get fx is equal to x 4 plus 3. And also here we find is x 4 plus 6. What's wrong? 1215, what's wrong? What's wrong? 551215. But why you missed my? Where call you? Where are you? Was couldn't. Yes, Max, you absent because I call you. You are not here. You have been late for a long time. Maybe after class I will consider it. Okay. And now because I think it's time to learn. And we have this is so H2 is an antiderivative of 4x cubed. In fact, this is not if this is not a 3, not a 6, we can write this is a C. C is the absolute constant, right? Absolute constant. C is any constant is an antiderivative of 4x cubed on our real line. So we can simply write. Here, this is a curve of the equation fx is x power 4, and x 4 plus 6, so it's upper, and this is x 4 minus 4. This curve. All these are the antiderivatives of 4x cubed, right? So we have infinitely x 4 plus 6. 4 plus 6. Now we pose an important question. Is every antiderivative of fx is 4x cubed of the form x4 plus c? This means do we have any other form except x4 plus c, right? And the answer is yes. This means every antiderivative of fx is the form x4 plus c. And this follows from theorem 6.3.6b, which is highlight if two functions have the same derivative, they must differ by a constant. This means if f prime x is equal to 4x cubed and g prime x is equal to 4x cubed. The fx and gx, this means they must differ by a constant. Fx minus gx is c, right? Differ by a constant. Our conclusion is this: if a function f has an antiderivative, it will have a whole family of them, and each member of this family can be obtained from one of them by the addition of an appropriate constant. We call this family of functions the general antiderivative of c. It's the general. This is plus c. The general. After we get used to this notion, we will often omit the adjective general, just the antiderivative. Okay, antiderivative. Example 2 is find the general antiderivative of f(x) is x squared on the zero line. We can think this means we want to find a function of prime x is equal to x squared, right? You can think of it. Fx, you found fx is equal to. This means you can calculate the derivative, right? But this is the inverse process. This is f(x). If prime x is x squared, you can think of fx is equal to. Yes, x squared plus 12. No. X squared plus 12. No. And prime x is x squared. So we find here. This means from we have power zero, the derivative. We have power zero. This means fx. Yes, you're right. We know fx is x cubed. Will not do since. Will not do since its derivative is 3x squared. And we want to x squared. But this suggests fx is 1 over 3x cubed, right? Which satisfies f prime x is x squared. However, the general antiderivative is 1 over 3x cubed plus c. This is the general antiderivative. We will often omit the adjective general. So we find fx is equal to 1 over 3x cubed plus c. This is every antiderivative have this form. Okay. And this is notation for antiderivatives. Since we use the symbol dx for the operation of taking a derivative, it would be natural to use ax for the operation of finding the antiderivative. Because the first word, this is a, right? A. Thus, we can write it ax x squared is 1 over 3x cubed plus c. This is a notation used by several authors, and it was in fact used in earlier editions of this book. However, this Leibniz's original notation continues to enjoy overwhelming popularity, and we therefore choose to follow him. This means rather than ax, Leibniz chose the symbol. This one, we write like this. Here, the whole like this. It's not ax. And K-dot is ax x squared. K-dot is like this is x squared dx. Like this, x squared dx. We know it's 1 over 3x cubed plus c, right? And we find this is 4x. And before we have learned this one. 4x cubed dx is equal to x4 plus c. You write this is 4x cubed dx. You want to find the right fraction. This means you should find the fraction is f, and prime x is equal to 4x squared, right? 4x cubed. So you should write here fx is x power 4 plus c. This is general and antiderivative. And Leibniz choose to use the elongate s. This is s. We have s like this. And the dx, for reasons that will not become apparent until the next chapter. For a moment, simply think of this one as indicating the symbol as indicating the antiderivative with respect to x. So with respect to x, just as dx indicates the derivative with respect to x. So this we have x. This is the antiderivative with respect to x. And note, do you know why? Do you know why this equality succeeds? This one, dx. So why dx fx dx is equal to fx? Here, this means with the first antiderivative, right? And then derivative. And we will create if we find a right here. If fx first, we calculate this one. If fx dx, this means we should find an antiderivative of fx. I write if it's fx plus c. Okay? And then this take a derivative. So take derivative dx here. This is the same dx. Right? The dx. Dx, then we write this dx fx plus dxc. Right? dxc. The linearity. And then dx fx right here. dfx fx is equal to fx. And dx is 0. So it's equal to fx. Right? It's equal to fx. And then this one, do you know why this one succeeds? This is the first derivative and then antiderivative. You know, derivative and antiderivative are inverse, right? They are inverse. So this means just like first plus, then minus. So this is no operations, right? They can cancel. So first derivative, antiderivative, and then derivative. So it is just the no operation on this function is fx. That's yes, it's integration. It's also called antiderivative. Do you know why this one? Do you know how to understand this one? The second equality. Yes. Why? You can say dx fx, right like this. Right is f prime x, okay? F prime x dx. Okay. Right, f prime x dx. And we know this symbol, right? This symbol, this we simply think of this as indicating the antiderivative with this vector x. This means we want to find our function because the derivative is equal to f prime x, right? So it's just the fx plus c. This function, this means the function is fx plus c directly down. Okay. And to establish any result of the form, all we have to do is to show right. This means if we want to find this fx plus c, all we have to do is to show right. dx fx plus c is equal to fx. This means if you check whether your result is right or wrong, maybe you just show fx plus c, this prime, this derivative, yeah, is equal to fx. Okay, so we have in the in the previous section, we learned the power law. Is taught us how to calculate the derivative. But here we will also have power is to calculate the integration. Is if r is any rational number except minus 1, and then we have is x r dx is equal to x r plus 1 over r plus 1 plus c. Is this one. Because in the power law we know x XR is equal to R x R minus 1, right? This is we learned parameter in the previous section. And here is the XR integration is equal to R plus 1 XR plus 1 over R plus 1 plus C. And we will put this. If we want to put this, we have to do is to write dx fx plus c is fx, right? So this means we should show dx xr plus 1 over r plus 1 plus c. Calculate. This is by parameter is equal to r plus 1 times x r over this is r plus 1 plus 0, right? So we find this xr. Find this xr. Oh, we find this is xr here. The way forward, right? So this is opposite. Right is opposite. And we make two comments about theorem A. First, it means to include the case I is 0. That is, VR is 0. Is XR dx is equal to 1 dx, right? Is equal to x plus c. X plus c. Is equal to x plus c. Second, since no interval I is specified, the conclusion is understood to be valid only on intervals on which XR is defined. In particular, we must exclude any interval containing the origin if R is less than 0. Less than 0. Okay. And following Leibniz, we should often use the term indefinite integral in place of antiderivative. Okay, this means we will always call it indefinite integral. This is indefinite integral. To anti-differentiate is also to integrate. This means integrate. In the symbol fx dx, this one, this here, right here, this is called the integral sign. Integral sign. And fx, here, this one, integral sign. Fx, this is called integrand. Integrand. Thus, we integrate the integrand and thereby evaluate the indefinite integral. Perhaps Leibniz used the adjective indefinite to suggest that the indefinite integral always involves an absolute constant, right? Always. Don't forget to plus C. Always involves an absolute constant. Okay. And now we will calculate exam 3. We will do exam 3 together. This is x, maybe.死机了。Yeah, because he has learned it before, so it's very simple for him. 哦，死机了，那我重新再关机开机吧。1204法西姆 ，right？ 法西姆 ，yes， your answer, you're right, it's true。马上关机吧。 This one. Hello. And we have here exam 3. Find the general antiderivative of f(x) is x 4/3. Okay. We should use the power law. Right? Power law is x r dx is equal to x r plus 1 over r plus 1 plus c. Right? Here, this means r is 4/3. R is 4/3. Here this is 4/3 dx is equal to 4/3 plus 1. X is 4/3 plus 1 plus c. Right? So 4/3 plus 1 is equal to 7/3. 7/3 over 7/3 plus c. We can write is 3/7. X 7/3 plus c. Right? And note that to integrate power of x, we increase the exponent by 1 and divide by the new exponent, right? Increase by 1 and divide by new exponent. Antiderivative formulas from the sine and cosine fractions follow directly from the derivative. Sin x dx is equal to this is minus cosine x plus c. Okay, this is minus cosine x, and the cosine x dx is equal to sin x plus c. And we can simply note that if we prove the first, this means we should know dx minus cosine x plus c is equal to sin x, right? And the second way for dx sin x plus c is equal to cosine x. And we also know derivative is a linear operator, and the indefinite integral is also linear. Recall from chapter 2 that the dx is the linear operator. This means two things. The dx k f(x) is equal to k times dx. dxf plus g is dxf plus dxg. And this is dxf minus g is dxf minus dxg. So it turns out that indefinite integral also has these properties of a linear operator. So we have theorem C. The f and g have antiderivatives. It's indefinite integral, and let k be a constant. So we have, if we calculate k f(x) dx is equal to, we can write k in the front and then calculate f(x) dx. And this f plus g, you can write it f(x) dx plus gx dx. And f(x) minus gx is equal to f(x) dx minus f(x) gx dx. Right? And the next, we leave it to you to operate. Okay. And here, this using linearity of indefinite integral evaluate ABC. Maybe ABC we do it by ourselves. Okay, quickly. First one, 3x squared plus 4x. B is u 3/2 minus 3x 3u plus 14 du. And C is 1/t squared plus the square root of t dt. Just by the linearity and the power law.
linearity. Indefinite integral.
Here is the Pasimos. Activity Pasimos. X squared plus 4x is equal to linearity. Right. Right. 4. Yeah, right. Plus C. Yes, A right. Pasimos. Your answer is right. Okay, let's repeat. Let's answer. Oh, right. 3C1 plus 4C2. You're right. Is absolute constant C. Right. Let's see the second page. Yeah, right. 14. Right. Is U. It's 5 over 2 over 5 over 2 minus 3 over 2 U square plus 14U plus C. Yes, right. Okay, right. Read the last one. Function. Let's check it. X cube plus 4x squared over 2 plus C. Right. B is equal to U. Yeah, right. Oh, yes, you're right. Yes. However, the exponent plus 1. Continue. Yes, you're right.哦，法西木哦，1204不是法西木。哦，1204是。Okay, number C. Oh, C. And C is minus 2 minus T minus 1 plus 2 over 3. T 3 over 2 plus C. Right. Oh, I see your answer, Lily. T1 over T square plus this one. Right. Amos 写完了吗？于连写完了吗 ？Finish, finish 2, finish 1, finish A. Okay. Now maybe let's see 1204. Let's say 1204's answer. Okay. 1204 here. This one. Three 写呢？3x square plus 1204. I hope you can write 2 like this. Yeah? Write 2 like this. This is 2. Okay? 1204. I hope you write 2 like this. This is 2 and x like this. 3. By the linearity, this 3x squared plus 4. Hope you write 4 like this. This is 4. Okay? 4. 4 like this. 4. 4x dx is equal to by the power law is equal to here linearity. This 3 is a constant k, so you can write 3 in the front, and so the integrand is x squared by the power law is 1/3 x3 plus 4 is also a constant. So write 4 times 1/2 x squared plus c. So the final answer is x cubed plus 2x squared plus c. Right. Okay. This is A. Now we see. 那么多。Say B. B, I will say maybe fascimus. Okay. Another students, I choose another students. Look at this one. Fascimus. This is B. Okay. B here is this one. B is U 3/2 minus 3U plus 14. So by linearity, we can first calculate this one, and we just use the power law, the exponent plus 1. So it's 3/2 plus 1, exponent plus 1, and divided by new exponent. So it's 3/2 plus 1. We simplify it is u 5 over 2 plus 5 over 2 over 5 over 2 minus this is u. So it's 3 times the u exponent plus 1. So this is 2. If this is the power is 2, so the exponent divided by the new exponent is also 2. And here this is 1. 1 we just this is the special case. This is u. So it's 14 u plus c. Right. This is the right answer. Just you use for right this. Okay. Okay, let's see the last one. Last one. This is the last one. Yeah. Here, last one. The last one is 1 over t squared plus the square root of t dt. So we can write 1 over t squared is equal to t, the power is minus 2. And the square root of t we write is t, this power is 1, exponent is 1 over 2. And so by the power law, this is the minus 1, t minus 1 plus, here this is 2, the exponent plus 1, 1 over 2 plus 1, over 1 over 2 plus 1. So it's 2 over 3, t 3 over 2 plus 6, right? So this is right. Any questions? A, B, C. Hello? Any questions? No. Okay, we continue. And then we will say this generalized power law. Recall the channel is applied to a power of a function. We have if u is gx is a differentiable function and r is a rational number, I is not to the minus 1. Then we have dx u power r plus 1 over r plus 1 is equal to this, we should use the channel. Which the channel, so it's equal to ur, right? Ur times dxu, because by the channel ur times dxu. R in fractional notation, we have dxu is, if u is gx, the gx power is r plus 1. We have this is gx power r times g prime x, because u. This means u is gx. And dxu is g prime x. From this, we obtain an import law for indefinite integrals. We have in theorem D is generalize the power law. Here we like g be a differentiable function and r a rational number different from minus 1. And then we have this gx, gr. Here this gx the power r, the times is g prime x, g prime x dx. We have from this, we will find the antiderivative of this function. We know dx, this one is equal to here, this function. So this is equal to gx r plus 1 over r plus 1 plus c from this, right? From this. Okay, and to apply d, we must be able to recognize the function g and g prime in the integrand. This means you should recognize g and g prime x, because this is not always obvious. For example, here, this one, evaluate a and b. We remember this is gx. Here, this is the power r g prime x dx is equal to is equal to gx. This power is r plus 1 over r plus 1 plus c, right? Plus c. Plus c. Plus c. So this means we should recognize gx and g prime x here. From here, to know which gx. Here, gx. Can you tell me gx? Yeah, this one. Gx power r times g prime x dx is equal to gx, the power is r plus 1 over r plus 1 plus c, right? So please tell me the recognize gx. Which one is gx? Finger, which one is gx? A. gx. Huh? Relate. Gx. Yes, gx is x4 plus 3x. Right? We write this is we write gx. Gx here. This one. This is r is 30. Right? This is g prime x. We know if gx is x4 plus 3x, then this one is g prime x dx, right? So it's equal to r plus 1. 30 plus 1 is gx r plus 30 plus 1 plus c, right? So if we know gx is 31, gx is equal to x4 plus 3x. This the power is exponent is 31 plus c. So we have to do that, right? This is gx. And b, please tell me gx is equal to sin x, right? This is we can write is sin 10x. This is cos x. We can write is sin x prime dx, right? So gx is sin x. And here, by the generalized power law, we have this is 4 plus 10 plus 1. This is sin 11x plus c, right? So we get the result of B. Any questions for this? Any questions? Okay, now we continue. Okay, and example 5 shows why Leibniz used the differential dx in this notation. If we like to use gx, example 5, which is example 5. like this. Example 5, write with this one. Sin 2x cos x dx. And we write this sin 2x is cos x dx. Write is sin x prime dx. Okay, sin x prime dx. If we let u is gx, here, this means if we let u, if for example 5, I let u because sin x is gx, right? We let u is sin x. Du differential is equal to sin x prime dx, right? Sin x prime dx. So I replace the sin power 10 sin prime x dx by substitution this one into the upper. So I have this u power is 10. This is du, right? This one replace this is du. So this means we can use power there. Right? So this is 11 u11 plus c, right? And in the final, which the replace u by because u is sin x, so we is sin x 11 over 11 plus c, right? Plus c, and this is which is the from this one here is the ordinary power rule with u as a variable. Thus, the generalized power law is just the ordinary power law applied to functions. But in applying it, we must always make sure that we have du to go with ur. The following examples illustrate what we mean. Example 6. Please have a try yourself. Example 6. This is x cube plus 6x. This power is 5. And times this one times is 6x squared plus 12. And here b is x squared. X squared plus 4, 10x dx. Okay, maybe we do A together and then B you finish it. Okay, we do A together. Here, now we example 5. Write u is gx. This is u is sin x. And A here we also can write u is gx. This means gx is equal to gx. Yeah. X cubed plus 6x. And then we should calculate du, right? So from this we find du is equal to du. Du is equal to 3x squared plus 6, right? Don't forget this is dx, okay? Dx, don't forget dx. And but here is 6x squared plus 12. It's not the same, right? So we can write this is equal to, this one is equal to, we write is u, this power 5, right? And we know 6x squared, 6x squared plus 12. This is 3x squared plus 6. So it's twice. So it's equal to 2 du, right? If this times 2, the same. So it's equal to 2 u 5 du. This is ordinary power law. Okay, ordinary power law, we can calculate is 2 times this u 6 over 6 plus 6, right? And then you should replace u by this is 3. U is equal to x cubed plus 6x plus 6. Okay? We have this one. Hey, and questions? This one? Linearity. Just learn it. K of x dx is equal to k times f x dx. It's a linear operator. Just like the differentiation, it's a linear operator. Dx is also linear operator. So antiderivative is a linear operator. So I just write t two in front. Right? This is what you want to ask. Okay. And B, let's have a try. B, quickly. B. Let's say let's say 这是哪一个的？看看。1204 Hello, 1204 You forget du is equal to 3x squared plus 6dx. Okay, you forget dx. You forget to add dx. No dx everywhere. You omit dx everywhere. 2du is this dx, okay? Over 2. Oh, right. Massimo, your answer is right. Okay, let's take Lily's. Let's take Lily's. Let u is x squared plus 4. du is 2x dx. And x squared plus 4 x is equal to 22. All right. Yes, you're right, Lily. Right. Haha. Hello, as you forget dx, okay? Please remember to write dx. This differential is not a differentiation, okay? Let's see Fashimon's answer. This one here. Highlight x squared plus 4 is z, right? This word is z. And t 2x dx is equal to dz. This means x dx is equal to dz over 2. So the original indefinite integral is equal to this is z power 10 dz over 2. So it's 1 over 2 z 10 dz is equal to 1 over 2 z 11 over 11 plus z. And then replace z by x squared plus 4. Okay, guys, the answer, the right answer. Right. Any questions? You answer which is that? Which one? Yeah, you answer first. You answer the first, right? You forget D. Actually, here, let me show it for you. You forget D. I see your answer. Here, this is your answer. Oh, this is not your answer. But the second picture, I didn't receive it. The second picture, I didn't receive it because the byte internet. I can let me see if I can show it. Oh yeah, okay. I say your right answer, 124. You change your answer here, right? This is the answer. Oh right, this is 11, right? This is x squared, right? This is square. This part, this is 2. Oh, this is 2. Oh, suppose u is x squared plus 4, du is 2x dx. Right. This part is right. Okay. Any questions? Any questions? Any questions? You should say which one, which process. You got it? No questions, are you sure? Julia, 懂了没？ Huh? Do you understand it? You don't understand? Maybe you can sit together, talk with each other when we do exercise. Because continue. Here's the right. Okay. Let's see. Here. This is our homework. Okay, this is our first homework. Hello. This is our homework. 19, 20, 25, 27. Homework. Please send your homework to my email. 今天星期三。星期三。Next Monday. Okay, next Monday. Okay. This is homework, not an exercise in class. Okay, this is the homework. Don't forget to hand in. Okay. If you know, then another page. I will show another page. Oh, this is the last page for lecture 04. When you send your homework, please write your ID. Okay, please write your ID and your name. Write your ID and your name. Today we will learn lecture 5. It's a definite integral. Definite integral. We have two problems, both from geometry, motivate the two most important ideas in calculus. The problem of finding the tangent line leads us to the derivative. The problem of finding area will let us the definite integral for polygons close the plane ridges bounded by line segments. The problem of finding area is hardly a problem at all. We start by defining the area of a rectangle to be the familiar length times width, right? And from this, we successfully derive the formulas for the area of a parallelogram, a triangle, and any polygon. The sequence of things in Figure 1 suggests how this is done. A rectangle. The area is length L times the height W, omega, the omega. And the area of parallelogram is equal to this A is, if this is B, the length is B, and the height is H. So it's B times H. B times H. And triangle. Here, this is a triangle. A triangle is the half area of a parallelogram. So it's equal to 1 over 2 BH. And the polygon, we can depart it. Is A1, A2, A3, A4, A5. The sum of A1, A2, A3, A4, A5. Even in this simple setting, it's clear that area should satisfy 5 properties. The area of a plane ridge is a non-negative real number. The area of a rectangle is a product of its length and width. Both measure in the same units. The result is in square units, for example, square feet or square centimeters. The congruent ridges have equal areas. The area of the union of two ridges that overlap only in a line segment is the sum of the areas of the two ridges. If one ridge is contained in a second ridge, then the area of the first ridge is less than the or equal to that of the second. When we consider ridge with a curved boundary, the problem of assigning area is more difficult. However, over 2,000 years ago, this Archimedes provided the key to a solution. We consider a sequence of inscribed polygons that approximate the curved ridge with greater and greater accuracy. Here, that means if we want to calculate the area of this circle, and we can use a polygon. This this one, we have if this area is P1. P1 is to approximate the area of this circle. And then we can find a sequence of inscribed polygons that approximate the curved ridge with greater and greater accuracy. Then we have this is a P2. Then, for example, for the circle of radius 1, we consider regular inscribed polygons. This is P1, P2, P3 with 4 sides, 8 sides, 16 sides, as you in Fig 2 here. These are 4 sides, 4 sides, 8 sides, 16 sides. The area of the circle is a limit. The area of a circle is the limit as n approaches infinity of the areas of Pn. The areas of Pn we write is APN. This means if AF denotes the area of a red F. This means a circle is equal to the limit n approaches infinity APN. This is APN. The Archimedes went further, considering also circumscribed polygons. T1. This is also a same circle with radius 1. This is a circumscribed polygons. This with size 4 sides. We write this T1 and T2, T3. We should write you get the same value for the area of the circle of radius 1. Whether you use inscribed or circumscribed polygons, it's just a small step from what we did to our modern treatment of area. Okay, we have sigma notation. Our approach to finding the area of a curved ridge R will involve the following steps. First, we should approximate the ridge R by n rectangles where the n rectangles taken together either contain R, producing a circumscribed polygon, or are contained in R, so producing an inscribed polygon. Second, find the area of each rectangle. Third, sum the areas of the n rectangles. Last one is take the limit as n approaches infinity. So if the limits of areas of inscribed and circumscribed polygons is the same, because this limit the area of the ridge R. And step 3. Step 3 involving summing the areas of rectangles requires us to have a notation for summation as well as some of these properties. Consider, for example, the following sums is 1 square plus 2 square plus 3 square plus 100 square, and it's A1 plus A2 plus A3 plus A4 plus AN. To indicate these sums in a compact way, we write this sums as this one. We write is sigma I from 1 to 100. This is I square, right? I square. And this means Vi is 1. Vi is 1. This is 1 square plus I is 2. This is 2 square. I is 3. So this is 3 square plus I is 100. So it's 100 square. And this one we write is sigma I from 1 to n AI respectively. Here, capital Greek sigma, which corresponds to the English s, such that we are to sum or to add all numbers of the form indicated as the index I1 index. This index I runs through the positive integers, starting with the integer showing below sigma and ending with the integer above sigma. Okay, this is start with the integer shown below sigma and end with the integer above sigma. So if this is from I from 2 to 4, so this means start with 2. This A2, B2. 4, this end with 4. So the plus A3, B3. And this is plus A4, B4. This is the last one, right? And this is J from 1 to A. 1 over J. This means start with 1. Integer, start with the integer shown below sigma. So start with 1, end with n. 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over n. Okay, you should know this new symbol. Sums. Right like this. New symbol. And this one. This is the key start with 1, end with 4. So the k over k square plus 1 is 1 over 1 square plus 1, 2 plus 2 over 2 square plus 1. The last one is 4 over 4 square plus 1. If all the ci in have the same value, c, then this is c1. Here, this one is equal to c1 plus c2 plus the last one is cn. If all the ci have the same value, this means c plus c plus c plus c. We have n terms. N terms, I thought it out. This n terms is equal to n times c, right? It's n times c. In particular, we have if c is 2, this is n is 5, I from 1. So this is 5 times 2 is 10. If I is 1, n is 100, c is minus 4. So it's 100 times minus 4 is minus 1, 400. We have properties of sigma. Such as an operator. Sigma operates on sequences and it does so in a linear way. We have linearity of sigma. This means if c is a constant, then we have this I from 1 to n cai. We write is ca1 plus ca2 plus can. Here we can write because they have factor c. Where c, this is a1 plus a2 plus an. It's c. Here a1 plus a2 plus an is sigma I from 1 to n ai. Right? So they are equal. And this is ai plus bi. We can write it sigma I start with 1 and with n. ai plus I from 1 to n bi. Minus is the same. Minus. Okay? Plus. This is called the linearity of sigma. Linearity sigma. And we have example 1. Suppose that sigma I from 1 to 100, ai is 60, and I from 1 to 100, bi is 11. Calculate this one. Then use the linearity is equal to 2 times I from 1 to 100, ai, right? And minus 3 sigma I from 1 to 100, bi, plus sigma I from 1 to 100, this is 4. And it's equal to 2 times, this is 60, minus 3 times, this is 11, plus this is 4 times 100. So it calculates 487. 87. Hello, any questions? Hello, any questions? For example, one? No questions. How about the other students? Any questions? Okay, we continue. This is collapsing sounds. Oh, first one. Maybe we have a break, okay? See, I'm gonna get tired. Have a break. Hello, everyone, have a break. Oh, I don't know. Actually, you can hear me. Okay. Okay, maybe can you try to show a tattoo per A? Last one. Okay, AB. When we finish AB, you can go home, have a sleep. 哦，明天星期四上午还有课，对吧？ We have class tomorrow. What? Huh? What? Chinese ceremony. Yes, you text it. 活动不能，你不能来上课吗？来。This is PM. Yeah. So we have classes morning and night, not PM. Alright. Okay, A and B. Please have a try to put A and B. A. A, this is A, I plus 1 minus AI. I from 1 to A is equal to AI plus 1 minus A1, A. I, this is A. I start with 1, end with N. So it's Vi is 1. This is A2 minus A1, right? Vi is 2 is plus A3 minus A2 plus I3. This is A4 minus A3 plus. Oh, you were thinking, girl. It's okay. I will take it later. Okay. And this is V. I is N minus 1. This is AN minus AN minus 1. Vi is the last one. I is N. So it's AN plus 1 minus AN, right? Minus AN. And here we show A2 minus A2, 0. A3, 0, right? And AN, 0. And this one also we can cancel. So only AN plus 1 and minus AN, A1 left, right? These two numbers left. So this is equal to AN plus 1 minus A1, right? This is A, we put it. And B, I is 1, the same for B, right? Same for B. Here we just, we can use A is a formula. This means we will write AI plus 1 is equal to I plus 1 square, right? And this means AI is I square. So this one from A is equal to AN plus 1 minus AN, minus A1. Minus A1. Minus A1. Minus A1 is equal to AN plus 1. AN plus 1 is N plus 1 square minus A1. A1 is 1 square. So it's equal to N plus 1 square minus 1. Right? We have this. Third, we have 38. AB. And questions? No. Okay. Oh, maybe I think this is not the last one. Okay, we will introduce this one. The symbol used for index does not matter. Thus, you use I from 1 is equal to, you use J from 1 and K from 1. And all these are equal to A1 plus A2 plus AN. For this reason, the index is sometimes called, this is DUMMY. Do you know how to pronounce it? Anyone can tell me? Dame. Let's check it. DUMMY. DUMMY. Dome index. And we will introduce some formulas. When finding areas of ranges, we will often need to consider the sum of the first n positive integers, as well as the sums of their squares, cubes, and so on. There are nice formulas for this. Verbs are discussed after exam 4. This one. 1 plus 2 plus 3 plus n is equal to n times n plus 1 over 2. Do you learn it before? No. From now, maybe you should remember. It's the first one. It's n times n plus 1 over 2. The second one is 2 square plus 2 square plus 3 square plus n square is equal to n times n plus 1 times 2n plus 1 over 6. Second formula. This cube. 1 cube plus 2 cube plus 3 cube plus n cube is equal to n times n plus 1 over 2 square. Last one, and maybe last one is hard to remember this. Okay, just the 1, 2, 3. The first 3. The 3 first. Okay. Example 3. We will find a formula. And a formula for this one. Maybe we will do it tomorrow. Okay. Yeah, tomorrow morning. Bye. Hello, everyone. Bye bye.
রে টিচার কই গেল?
টিচার চলে গেছে।
আল্লাহ, কত বায়ও বলতে পারলাম না আমি।
হ্যাঁ
বাই বাই বলতে পারলাম না টিচার রে।
আমি তো দিয়ে দেখছি।
মাই গড।
বাই বাই কি পাই পাই।
মেঘংশী।
সাপিউর কই সাপিউর?
তুফিকুর সে চলে গেছে।
সাপিউর আছে
আমি
দেখছি।
আমি এখন বাইরে থেকে একটু ঘুরে আসবো, কারণ ক্লাস করি কিছু বুঝি না, ওই জন্য ক্লাসও করি নাই। রেকর্ড করছি। হ্যাঁ, আমি রেকর্ড করতে দিয়ে চলে গেছিলাম, বাইরে ঘুরে বেড়াইলাম সত্যি।
আমি একজনের কাছে ফোন রেখে গেছি, আমি বলেছি যা শেয়ার করবে স্ক্রিনশট মারবি অটোমেটিক।
উইক 17 প্লাস 18, 18টা ক্লাস হয়ে গেল রে ম্যাথের।
কালকে আবার দুটো ক্লাস
19-20 হয়ে যাবে ফিট।
20 হয়ে যাবে আর আমরা কিছু জানি না এখনো।
বাকিরা তো ভাই দৌড়াইতেছে ম্যাথে।
সবচেয়ে ফাইভই ভালো, ফাইভ সবগুলোই পারে।
ম্যাথে তো আমাদের দেশের গুলাই ভালো পারে মোটামুটি, ওদের থেকে দেখি। ফাহিম ভালো পারে, তারপরে ওই নূর হামিম, তারপরে ওই নির্জন, শিপন, তারপরে সাকিব, তারপরে মুস্তাফিজ, তারপরে রায়হান, তারপরে আরেকটা সাকিব। খালি আমি পারি না।
আমিও পারি তাই।
ল্যাঙ্গুয়েজ অপোজিট, ল্যাঙ্গুয়েজ আমি পাকা।
ল্যাঙ্গুয়েজ তো পাকা হবে। আর
এরাও কি
আজকে
রেকর্ড করতে দিয়ে চলে গেছে নাকি?
সবকটা চলে গেছে। আজকে এক্সাম কিরম হলো?
এক্সাম কি কব, ভালো বলবো না খারাপ বলবো না, আলহামদুলিল্লাহ।
মানে আমি প্রথম যখন লিখছিলাম খুব ভালোই ছিল, হ্যাঁ। পরে ওটা সাবমিট নিচ্ছে না বলে এবার কেটে কিভাবে আমি কেটে ফেলাইছি। পরে আবার আর লিখছি,
আমি
লিখার পরে
তিনবার লিখছি, তিনবার লিখছি
আমি
আমি।
তো 3 বার লিখছি। লাস্টে না পারে খাতায় লিখে ম্যাডামের কাছে পাঠাই দিয়েছি।
হুম, তাও ভালো কাজ করছো।
ম্যাডাম আমার বলে কি ওই ফর্মে লেখার জন্য। পরে ওটা লিখে সাবমিট দিছে, তারপর জিজ্ঞেস করে নিয়েছি ম্যাডাম কোনো প্রবলেম হবে কিনা। তো ম্যাডাম বলছে না। ভালো ওই ফর্মে যে অনেক লিখা যায়, একবার লিখতে লিখতে যদি পেরে আসে জবাগিরি কেটে যায়।
আরে ওখানে কপিও করা যায় না, যেমন
কি এমন পেজ বানাইছে যে কপি পেস্ট কিচ্ছুই করা যায় না। বলো
আবার
চায় না আর কি।
আবার ব্যাক করলে আবার নাকি প্রথম থেকে লেখা লাগতেছে, একবার ব্যাক করলে হয় নাকি বলো?
একবার ব্যাক করলে তারপর প্রথমে
আরে ওইভাবে তো 3বার লেখা লাগছে আমার, হুট করে একবার ব্যাক করলাম ওই
আমার
আবার
টু ফলস
3বার।
আর হচ্ছে এখানে প্রথমে যেগুলো দিছিল শূন্যস্থানটা বাদে আর টিক চিহ্ন যে কটা দিল, টিক চিহ্ন সব কটাই ছিল। তারপরে ওই যে ট্রু ফলস সব কটাই ছিল। আর বাকি আর একটা কি ছিল না, শূন্যস্থান না
5
ওই যে
ধরনের
মিলানোর জন্য
প্রশ্ন
একটা
ছিল,
কি দিছিল না।
ম্যাচিং ম্যাচিং, চাইনিজ ওয়ার্ডের সাথে ইংলিশ।
ম্যাচিং ম্যাচিং সবগুলো আমার হয়েছে, একটাও ভুল যায়নি।
আরে ম্যাচিং
কিন্তু
তো আমি গুগল ট্রান্সলেট দিয়ে করছি আমি।
ম্যাচিং গুলো আমার সব হয়েছে, ম্যাডামের স্ক্রিনশট মেরে রেখেছিলাম, ওই দেখে দেখে গাবাই দিয়েছি।
তা ভালো ভালো হয়েছে তো পরীক্ষা তাহলে সবারই।
সবারই মোটামুটি ভালো হয়েছে, কিন্তু আমার সময় চাইলো 3 বার লেখা লাগলো এই।
এখন সামনের পরীক্ষাগুলো তো খেপাবে ভাই, ল্যাঙ্গুয়েজ
সবগুলো
এক্সাম আর
তো
ম্যাথ
ইজি
এক্সাম।
হবে। আমি পিসিতে প্রশ্ন রেখে দিয়েছি আর ফোনে সবগুলো পূরণ করেছি।
আমি আগে গেলে কালেক্ট টালেক্ট করি, তারপরে করছি আর কি। ল্যাঙ্গুয়েজে যদি ক্যামেরা অন করতে কয় বলছো, ক্যামেরা অন করবো না আজকের মতো।
আমি তো ম্যাডামের বলে দিয়েছি আমার
ওই যে
পিছিতে আমার কোনো ক্যামেরা নেই।
তোফাইল বললো না যে ম্যাডাম আমি পিসিতে ক্লাস করতেছি আমার ক্যামেরা নাই, ওইরকম কল লাগবে।
ওই কারণে তো আমি পাইছি কিছু এই হয়।
আমি প্রথমে তো ক্যামেরা অন করছিলাম, পরে অফ করে দিছি।
একটা ছেলে দেখলাম ক্যামেরার সামনে লেখছে, হ্যাঁ ম্যাডাম আবার সেটা সামনে স্ক্রিনে রেখে দিয়েছে, তো ও শালা কিছু লিখতে পারছে না। ওই
ক্যামেরাটা অফ করে
ক্যামেরা
সব পড়া শুরু করে দিছি ভাই। সবাই বাড়িতেছে রে, কে কে আছে?
আপনি মনে হয় ঘুমাই গেছে।
ওদের দেশে কয়টা বাজে এখন?
মোরক্কর গুলাকে
12:30 মনে হয়, 12:30 অথবা 1:30।
দুপুর
হ্যাঁ।
দুপুর 12:30 31।
কে আছে এখানে? সাবেত আছে। হোয়াট টাইম ইট নাও ইন মরক্কো? 1 PM, 1:30 or 2:30 or 12:30?
1:30।
এটা কখন? 6:31 না? 5, 4, 3, 2, 1:31, 1:31। ওয়েট। তানভীর আহমেদ ভাই, লো
ভাই,
ভাই
কই
মাইক অন করেন, একটু কথা কই। না এই ভাই সাথে কখনোই কথা হয় নাই, গ্রুপ কলেও কখনো থাকে না, কোনো জায়গায় থাকে না।
তানভীর তো নিজের
লো হ্যালো হ্যালো তানভীর তুমি কোথায়?
শাফিউর, আমাকে শুনতে পাও?
না, আমি তোমাকে শুনতে পাচ্ছি না।